Don't make nice. So in the last session, we have discussed about averaging methods, right? We are revising the syllabus now. So today we will try to complete Unit 2 briefly, right? We are not discussing in detail. We will be discussing what is the concept and how you can apply. Okay. So here today in the Unit 2 we had the basic probability definitions, right? That are, so what is meant by generally probability? Why you need probability? Why you want probability in general? Why you need probability? So probability is something that is uncertain things. Like if we want to know, like by knowing the things, we can get to know that the future, like what is going to happen. It may or may not happen sometime, but we'll be trying to predict, right? Because the rainfall that are happening now, because so that like if you give some instruction to the near to the beach areas, right, people, so that they'll have some alert, so they can plan for something else, right? Rather than all together in the, what happens if you are not informing them during the rainfalls or whatever happening, right? Tsunamis. If it doesn't inform, the village will collapse. So that is why if you prior information, always better. Even though if it doesn't happen, they'll go there and then again they come back to the same position. So now probability mostly lying between 0 and 1. These are the axioms of the probabilities. That first one is the sum of all probabilities is equal to 1. The maximum is 1. I have told you why it is 1. Why it is 1? Why it is 1? Because most of the calculations, whatever we do, that will be for 100%, right? So that 1 is nothing but 100%. Okay. And another property is it always lies between 0 to 1. And first one is sum of all probabilities is equal to 1. Means the probability of sample space is equal to 1. What is meant by sample space here? Sample space is all possible outcomes will be included in sample space. So that is called sample space. Okay. Yes, see, these are the some of the examples where you can see regularly, right? Tossing a coin, throwing a die. These are the some of the examples where you can see the probability. Next. So these are the some experiment that if you see, let us say when you toss a coin. So whatever the possibilities you are saying, right? These possibilities we say that is sample space, right? Either head or tail, anything possible, right? One time when you toss a coin, but when you toss it twice coin, then all possibilities when you are writing, this is called the sample space. Yes. And after that, after the sample space, sometimes what happens is most of the time they will ask you to calculate the specific probabilities. Like I want only this possibility. To get this possibility, what is the probability? Like head possibility. When you toss a coin 5 times, they may ask you to calculate the probability of getting a head. Even though we are tossing a 5 times, but they expect to have something else like only head possibility, only tails possibility, both the times tail possibility, both the times head possibility. So this is the way they may ask you, right? And this is the basic definition. You can see here, right? This was the basic definition that we are looking at now. The number of favorable outcomes by the total number of possibilities, right? In a random experiment, whatever the experiment that you take. So this is the basic probability definition, and it lies between 0 and 1, right? Okay, you can see this. So these are the some of the possibilities that we are having. Like let us say rolling a die. When you roll a die, I want the probability of getting multiples of 3. So when you roll a die, what are the possibilities you'll get? What are the possibilities, ma? 1, 2, 3, 4, 5, 6, right? Now in this, what are the multiples of 3? What are they? So multiples of 3 is 3 and 6, only 2. So that is why 2 by 6 here. Okay? And 1 by 3 is the probability. Similarly, you can also calculate even number, odd number, getting a odd number, even number. They will also ask you sum on the both number when you roll a die twice. Some possibility they can ask you 12. What is the how many possibilities are there? So this is the way they can ask you many questions. Okay. Next, as of now, we discussed what is meant by sample space. Sample space is the sum of all possible outcomes, that whatever the outcomes that we have in the system that you have to take. That is called all possibilities, whatever is there. Those possibilities we are mentioning as sample space. Okay. So these are some of the examples you can see. Okay. Next. So what is meant by event? Event is something, it is a subset of the sample space. Means sample space is generally we have the entire system. In that you will be looking for some event. Right? Let us say we have a fest, college fest. In the college fest, you may have some particular event, right? So you may be looking for what is the possibility to happen that particular event. So that kind of scenarios when we have, that is called the event. That is why we say that event is a subset of the sample space. Okay. Next, anyway, these things you can read out. Yeah, you can see a fair six-sided die, means 6 sides only will have, right? Fair die. So roll twice. When you roll a die twice, what are the possibilities you'll get, ma? Right, sample space, yes. When you throw a die twice, what are the possibilities you'll get? Huh? What are the possibilities? 1, 1, 2, right? And so on till 1, 6. Similarly, 2, 1, 2, 2, 6. 3, 1, 2, 3, 6. So this will be extended till where? 6, 1, 2, 6, 6. This is because when we throw a die twice, these are the possibilities. Now the question is, we want the probability that sum of the dice is either 7 or 11. So first to calculate the sum, there are two events here. One is, let us take event as an event. So getting a sum 7, right? And another event is, what is another event? E2, getting a sum 11. So now for 7, what are the possibilities you'll get? 7, what are the possibilities? Huh? What are the possibilities you'll get? 1, 6, 1, 6, then next 2, 5, next 6, 1, 5, 2, 3, 4, 3, 4, 4, 3. So is there any other possibilities? No, right? So therefore 6 by total, how many are there here? 36. Similarly, we have to calculate for E2 event also. Getting a sum 11 as an event. Okay? So calculate probability of E2. E2 is 11. How many possibilities are there? 11. 2, 6, 6. No, 6, 5 and 5, 6. Okay? These are two possibilities. So 2 by 36. So 1 by 18. This is the way you have to calculate the probabilities. Now we have to add them both. You can see here. The total favorable cases is now probabilities. You have to add both. Is that clear? Any doubt in this? Similarly, you can solve all the problems. red card. So sometimes you can see here without replacement. The word is very important, right? When you say the word without replacement, the card whatever we are picking, again you are not replacing. So in that case, the card will, when you for the second event, the card may reduce, right? So that is why you can see here the total number of cards you may have only 52, but the probability that we want to calculate, see here, they mentioned clearly without replacement. Then what is the probability that both cards are either red or face cards? So how many red cards will be there? The total red cards is 26 and face cards is 12, right? Now first one we are considering one by one, right? Both are red. So for possibility for both cards is red is this one, because these are independent events. That is why you are multiplying here, right? The events are independent. So here what we are doing, initially we may have 26 by 52, and the card that whatever we are picking, again you are not replacing this. So when you doesn't replace, so in the 26 will become now 25. One card is already left, right, and divided by 51. So that is why we have got this one. Similarly, both cards are face card. Face cards also the similar version. And now add both of them. Okay. So this is the way you have to calculate. Last. Listen here. And next is, so sometimes they may ask you the rolling a die divisible by 3. Anyway, you can solve this problem, Nama. Similar models you can solve it, right? I'm skipping these problems. And now you can see that addition rule. Addition rule. See, the previously what happens is the intersection value, whatever we are saying, right? So that value become null set actually. Sometimes that value will be there. So in that cases, one has to use another formula, right? So that is why we are introducing the addition formula, right? Addition rule in the probability. So that is, addition rule is here. If you have two events, either A or B to happen, right? If you want to calculate the probability of either A or B, right? So that we have to calculate individual probabilities, and from the individual probabilities, you have to subtract the common entries, because we have to get, let us say we have with the Venn diagram, you can try to understand this. So here this common area is A intersection B, right? And this is A, let us say this is B. So the entire area is A union B. Now this A union B, if you want to get, we want A or B value area, not a common area, right? You can say. So now if you want that, so this area plus this area, and you can subtract this. So that is why you will be getting, so that you will be getting probability of A union B. So that's how the addition rule works, right? So now you know this complement formula, right? P of A complement is 1 minus P of A. Remember this, because sometimes you may require to use this formula. They can give you the general probability of A. They will ask you to calculate the complement of that. Okay. So similarly, if A is subset of B, then definitely the probability of A is subset of B. You can see here, let A comma B even, then there are some set operations. A or B means A union B, because we are writing in English notation here. A union B means event A or event B occurs. A intersection B means both occurs. And right, A complement means does not occur. Whenever you see the word does not occurring have probability, means you have to calculate the complement of that particular system. Okay, that does not happening probability. Okay, similarly A minus B means B complement. Let us say A minus B is A occurs but B does not occur, or B minus A means reverse. What will happen? So in this case B occurs but A does not occur. So this is how you have to understand. The wordings will be English, sometimes you may have right. So this you can try to understand them. And you can see here there was one problem on this addition theorem. So what they have given, a bag contains 4 green and 6 black and 7 white balls. A ball is drawn at random. What is the probability that drawn ball is either green or black? So they were asking only P of G and P of B. So we have to calculate P of G or G union B value. So from here, write down the probability whatever we know. Right? Overall, how much is there? Overall, how much? 17, I think, right? Total 17. For each one probability, for green probability is 4 by 17. For B is black bronze is 6 by 17. And now, is there any common area? They have not given any common, right? So that intersection value may be 0 here. G intersection B is equal to 0. Let us try. So both add and then you'll be getting the area. Clear? Simple. So green probability and black balls probability we have given, and because we do not have the common values, they have not given, right? So that is why we have taken as 0, and we can add them by applying the formula. Because when intersection value is 0, it will be removed, right? P of A intersection B, A union B, P of A plus P of B minus P of A intersection B. Now this value is not there, right? 0. That is why we are writing only 2. Okay. Next, similarly, you can try to understand this problem now. Okay. You can see here. So you need to understand the cards information also. Try to look at once actually the card information now, so that you can easily understand the like what kind of question they were asking, right? Accordingly, you can address it. Next. So here they will give you directly. You can see here there was some problem here. 60 students passed in first exam, 50 students passed in second exam, and both passed in 30 students in both exams. Now they may ask you find the both, like sometimes they may ask you either first or second. If they ask both, you have to add whatever the data we have, all the data you have to match, and then you have to apply the addition rule. Okay, do it this. Clear? Then this is done. Similarly, see, when we have a general probability addition theorem we discussed, right? Now, what is the need to go when we have addition theorem for the conditional probability? There are certain situations where one can see the conditional type of situation, right? So that is why one has to discuss about the conditional probability. That is the motivation, right? So you can see here the conditional probability of, let us say, the event. You can see here conditional probability is the probability of an event occurring, which the event is going to be happening given that another event B is already happened. Meaning, understand clearly, ma, whatever the event that is already happened, P of B event is already done. That is why we are adding in the denominator. And with respect to this, A event is going to happen. Let us say, if the person is good at math, let us say he is going to definitely pass in physics. So that's how if you want to calculate the probability, right? Sometimes. Clear? So if you want to, this kind of scenarios, one has to use this conditional probability. Okay? So this is defined as P of A intersection B by P of B. Because the B event is already happened, with respect to that only, the A event is going to happen. So that's how we are discussing, right? Clear? Any doubt in this, Mo? Now you see the problem here. So in this problem, let us see the total 52 cards well shuffled. Let us say they were mentioning that there are total 52 cards are there. They are well shuffled. A player randomly draws one card drawn one card from the decks, their packet, let us say. And let A be the event. They are giving A event as king probability, right? King. And B event as event B be the drawn is red, I think, right? They are mentioned red. Red means what are the things are going to come? Red cards are there in the hearts also and even diamonds also, right? So you should know better than me, right? Now, probability of A. What is the possibility for getting king? How many kings are there? How many kings will be there? 2, right? 2, total 2 king cards. No, total 2. 2 king cards by 52. Similarly, probability of B is here. Red cards means there are hearts and diamonds. Total 26, I think, right? 13, 13, 13 you may have. Division. So the total 26. So here probability of B is 26 by 52. Right? Now, what we want to calculate now? Try to understand the question now. If the player is already knows that the card drawn is red, means we are saying that whatever the card that you are going to pick, it is red card. It is fixed. That means probability of B event is already done. With respect to this, what is the possibility that is going to have a king? A, right? So that we want to calculate now, right? You can see here clearly. They have given. So the total red cards is 2, 1 from the diamonds and one from the hearts. And total intersection value is not intersection, right? Probability of B is this. And now, why we have taken intersection? Okay. We have to write the formula, right? How many king cards are there, ma? No, probability of A given B is P of A intersection B by P of B, right? Now, anyway, we have calculated P of A, but P of A does not require, I think, right? We required only intersection. Intersection, how you will get? Intersection value is how you will get? Intersection means the event should happen for both. Meaning, whatever the selected card will be a king card and as well as red card. How many possibilities? That is 2 only, yeah? That is only 2? Okay, 2. So probability of A intersection B is 2 now. So therefore, 2 by 52. And now P of B is already calculated. And substitute here in the given formula, right? P of A given B is equal to P of A intersection B by P of B. So this is about conditional probability. Now, next question is when we have addition theorem and multiplication theorem in terms of conditional, when we have these two formulas, why we need to go for the Bayes theorem? What is the situation that has tend to move for Bayes theorem? Whenever in the system, if I say here, right, the conditional statement, instead of A, let us say there king, you may have sometime if I say the black card or what something else, or you can also have some face card and both combination. Whenever we have a multiple conditional in the system, then one has to move with the Bayes theorem. Okay, you can see that. So these are some of the examples for the. You can read out that directly for a problem. You can understand easily, right? They have given 70% people drink coffee and 50% also like eat cookies. So this is the event that means while drinking the coffee, some people have some cookies, right? So this is already the event is going to happen definitely. So the probability they have given. Now they were asking us to calculate both coffee and cookies, meaning P of A intersection B you have to calculate now, not A given B, right? They have given you A given B and A probabilities. Look at here clearly, right? They were asking you to calculate this because they can ask you cross question. Be careful. Remember the formula and then apply. First, see the from the question what is the data is available with you. Accordingly, you can proceed. Right? Is that clear? So we know the formula for P of A given B. From that only we are writing, right? So that you can take P of B is the other side. So that we are getting this. Similarly, this problem also, the similar model, right? You can try. Now the independent event bar formula. What is the independent event formula? The independency, when you say the word P of A intersection B, we have to write P of A intersection B, will be writing P of A into P of B. Clear? The common entries can be written as multiplication of both entries, individual entries, right? Okay? Clear, no? Next, these are the some of the properties of independent events, because see whatever the formula that we discussed earlier, right? All the formulas can be modified. Let us say this property, right? You can also apply in addition theorem. How? Let us now, if I take P of A union B here, P of A union B is equal to P of A plus P of B minus P of A intersection B. Now, if I say the events are independent, instead of intersection A intersection B, we can write here P of A plus P of B minus P of A into P of B. So this is the way we can write. Sometimes you have to write this way also. Remember this. Okay, if we the same similar formula, intersection A intersection B is P of A into B, right? That also you can replace in A given B. P of A given B is, we are writing P of A intersection B by P of B, right? Now instead of this, if you replace this, what will happen? P of B will get cancelled. This will equal to P of A. Clear, ma? Similarly, vice versa also. Sometimes P of B given B given A, right? So in this case, P of A intersection B by P of A. Now this we are writing P of A into P of B by P of A. So P of A will get cancelled. So therefore, P of B given A will be P of B only. Because this scenario also required whenever you have the independency concept. If they give you directly, you can write this. See, sometimes instead of giving this P of B value, they can give you this value and they say that they are independent events. Okay? They can ask you in any way. Remember this. These are some of the properties now, right? That whatever we discussed, same. A intersection B, B intersection C, C intersection A. Next, you can see the problem on this. So independent event, right? So 20% of students participate in research club event A, 80% in sports club B. Now, participation in the research club and sports activities are independent of each other. Now, what is the probability that when you select the student randomly, what is the probability that he can participate in both research club and sports club activities? The event are independent, so you can use P of A union B, you have to calculate, right? But at the end, instead of A intersection B, you can use the independency concept. Okay? Similarly, for second one, at least one means either A or B, right? So we have to calculate either A or B. So P of A or B, A union B. Here both P of A intersection B. First one, second one is A or B. Now, what is the probability that a student participate in sports activities but not in the research club? Not in the research club means probability of B, because B is not right. He is participating sports but not in the A. Therefore, intersection A complement. That way you have to write. Okay? You have to calculate this. Similarly, other one also. So this is the way you are addressing, right? P of B complement B intersection A complement. This you can write it as P of B minus P of A intersection B. So we know these two values, you can substitute there, calculate the things done. Okay, clear? Next, similarly, this is one of the example, like directly they have given, right? You can read the formulas, you can read the question and then you can write it. Only try to understand the concepts. This is done now. Okay. Next. And you can see the base formula. So what is the situation? The requirement is whenever you have the system multiple conditionals, right? Statement in the model. So then we will be moving to base formula. You want or don't want more explanation? You want explanation or doesn't want explanation? You want, huh? So next is Bayes theorem. In a case where the conditional probability fails, right? So in that case, P of C, let A be the events, right? Group of events here. So A1, A2, AI, AN be the mutually exclusive event and exhaustive events also. That means A1 intersection A2, A2 intersection A3, A3 intersection A4, and so on. All common value if you take, you'll get null set pi. What is the meaning of this one? Mutually exclusive. Mutually exclusive means P of A1 intersection A2, A2 intersection A3, and so on. This values will get null set pi. Right? So whenever we have it this way, then there will be a P of A should be in the positive. With one probability is positive there. Then the probability of all the events, right? These are multiple values are there. So AI given B is already done. With respect to B, AIs are going to happen. So then you are writing in this way, right? P of AI into P of B given AI divided by sum of all those values. Because here you have multiple values there, multiple conditional probabilities. Okay? So in that case, we will be going to Bayes theorem. Now you see my here. What are the things are there here? Anyone? You have two bags. I think it is already done. Same. Bag 1 contains 3 red balls and 7 blue balls. Bag 2 we have 5 red balls and 5 blue balls. Now, when you select one of the two bags with equal probability, then you randomly draw one ball from the chosen bag. If the ball is red, what is the probability that it came from the bag 2? Tell me the probability how you will get now. Anyone? What is A1? A1 is the event is bag 1. Bag 1, right? Then what about bag 1? Let us say bag 1 we are assuming. And event E2 is this is E1 or A1, let us say A1. And next A2. A2 is we are assuming bag 2 event. What is the possibilities is even. So here we have 3 red and blue balls, let us say 3 and 7 in bag 1, right? And bag 2. 3, 7 is there bag 2 we have 5 and 5, both 5. Okay, now we want to calculate what we want to calculate first. What we want this. See the question, if you know the question clearly, answer is easy. First you should understand the question here clearly, right? Try to understand the question mark. You have randomly picked one ball from the selected bag. If the ball is red, that is clear, right? If the ball is red, that is clear. Now what is the probability that it has come from bag B? That means we have to assume one more event, right? That is, let us assume B be the event of getting a ball red. So now this is the related to bag ball red event, red ball, right? Because this event is already done. With respect to this, the event is going to happen, other two, right? That means, therefore, probability of B is already done. With respect to B, AI should happen, right? AI or A1, A2, we can say. AI should happen. So this probability you have to calculate. So first write this formula. What are the probabilities required here? So when you write this formula, we will be getting summation of, what is formula for this ma? AI given B is summation of probability B given AI by, what is probability? P of B is, both will get same, right? Base formula. If you use the base for, what is the base formula? AI into B given AI, right? So first you need to calculate AI, means individual event for getting a red, right? Similarly, next we also need to calculate B given AI, means AI is, the event is happening, with respect to that, the ball red should come. Let us say bag 1 if you take A1, because event A1 is back related to bag A1, right? A1 is related to bag A1, not clear, huh? Clear, right? Similarly, A2 is the event related to bag 2. So that is why, while calculating the B given A2, A1, you have to be very careful. Okay? Is it clear? You can see the probability now. This is how you will be calculating. So each event you have to calculate P of A1, A2. What is possibility for both? Then for getting a tran F, P given A1 means A1 is clear, means bag 1. The ball that you are selecting from the bag 1, but the probability part, probability that should get as a red ball. Red ball possibility is 3 by 10. Overall balls are 10. Red balls is 3. Similarly, A2, B given A2, right? A2 is related to bag 2. Bag 2 is clear. We are selecting the ball from the bag 2. But now you have to look for a red ball. So this is going to happen. So this probabilities also we have to calculate, and then we have to substitute in the given formula. Is that clear now? Bayes theorem. So Bayes theorem, most of the time, see, conditional statement, multiplication statement, and whatever we have discussed as of now. Till here, they can give you one question. Probability based, started with addition, multiplication, and Bayes theorem. So from this, you can get one problem. Similarly, averaging in the previous one, whatever we discussed right last class, unit 1, there also you can get one, right? And next remaining is from here, expectation. The same way you can do other things, right? I'm not discussing more ma, because we have a short time now. Clear? Okay, move further. Next, I'll give you another topic. Just only the concept. Yes. So the next one is the random variables ma. The random variables we started because the reason behind this is, as of now in the probabilities, whatever we calculated, right? We'll say that only we have said like red ball possibility. But there are questions like 1 red ball, 2 red ball, 3 red ball. There may be possibilities, right? Sometimes requirement is there. To understand this phenomena, they have introduced the concept of random variables. In the random variables, we can assign for each entity, the event that going to happening, right? For each event, we can assign the numerical values. We can easily calculate for, let us say, if I say something, right? king is going to happen. One time king, two time king, three time king. That way we can easily calculate. So that's how we can assign the values for the each event, each possibilities, right? So now you can try to understand here the same thing. So when you toss a coin, now this is the sample space we had, right? Generally what we are doing, if I ask you to calculate head probability, directly you are taking the head and then you are pushing out. But now in this process, one can say that 0 head possibility, 1 head possibility, 2 heads possibility. So all the things you can calculate here. Okay, that's how it works here, the random variables. Clear? And here random variables are two types. One is discrete and another one is continuous case. So in the discrete case, how the things will be? The things are able to countable. So that is discrete case, right? If suppose if anything that is not able to countable, so means that will be there in terms of intervals. So that comes under the continuous distributions, continuous random variables. So here discrete random variable, this also will assign each value some value there. That's all. Okay. In the continuous random variable, it takes the values in the interval. That means you'll be getting intervals for ranges. Let us say, so P of x, f of x is equal to, I'll be giving 0 if x is less than or equal to 1, x square plus 1 if x is greater than 1. So whenever we have this kind of scenarios, which interval type, time domains, then that comes under the continuous case. So now here also we have, like you can easily calculate for each one I said, right, possibilities. You understood this one? Clear ma? Assigning for each entry, like if I ask you, let us say when you throw a 2 dice, or not 2 dice, 2 coins. When you toss a 2 coins, will be what are the possibilities you are writing, right? Sample space, you'll be writing. Now I will ask you the probability that heads possibility. So when I say head possibility, here we have to calculate 0 head possibility, 1 head possibility, 2 head possibility, right? Meaning, like if you see the sample space, when you toss it two times, right? What are the possibilities you'll get? Head, HT, TH, and TT. These are the possibilities we'll get, right? Now, if I say 1 head possibility, now I will be writing the sample space, the event X is going to happen, right? So X is 0 heads possibility, 1 head possibility, and 2 heads possibility, because the maximum only we are writing 2 times, so we'll be getting 2 only, right? So now P of X is equal to, we'll be assigning the probability. What is the possibility for 0 head? 0 head is both tiles, right? So 1 by 3, 1 by 3 or 1 by 4. Similarly, 1 head possibility is 1 is here, 1 is here, 1 is here. Total 3 times. Therefore, 3 by 4. Then 2 head possibility is 1 by 4. Only one case, right? 1 by 4. So therefore, if you add all these probabilities, you have to get 1. You can also see 1 plus 3 plus 4 plus 4. I think this is 2, right? Sorry. This is 2. For 1 possibilities, we have 2 cases, right? So 2 cases. So one can understand from this also, when you add all these probabilities, you have to get 1. Then only whatever the assigning, the values, right, that are correct. Otherwise, something wrong in the model. You have to recheck the problem. Okay, Nama? Clear? Next. The same way you can see here. There are various problems on the same model. Clear? Next one is, you'll be calculating the mean. Mean? How you'll calculate mean? How you'll calculate mean? Huh? Mean for a discrete case, ma? Anyone? How you will calculate mean for a discrete case and continuous case? The formula is summation x into P of x. That is for the discrete case. But whereas in continuous case, the same thing, integral. Integral x into f of x into dx. Okay, you have to calculate. You can directly understand with expectation. So the expectation of x is, you will be writing as the expectation of x is equal to x into p of x. This is the formula for the calculating the mean in discrete case. Mean in discrete case. Okay. At each point you have the probabilities, right? Then you see the model problem. Therefore, x represents the outcomes of rolls of a pair six-sided die. Take the values from 1 to 6. Each possible probability is 1 by 6. Now, the expected value is the mean value, right? Each value will be getting 1, right? That is why I into 1 by 6. Therefore, 1 plus 2 plus 3 plus 4 plus 5 plus 6 by 6. Expectation of x into p of x. Because each place will get 1 by 6, 1 by 6, 1 by 6. Right? You understand this one? X are the positions ma. So x values are positions, right? 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6. Right? Same only you are writing in this way. Okay? Clear? In the case same thing. If you try to write in terms of continuous case, the formula is x into f of x into dx. Okay? And here also the sum of all probabilities is equal to 1. So that we will be defining from the infinite minus infinity to plus infinity value will be 1 in terms of integration. And these are the some of the properties of expectation ma. Linearity, because when you take linear property like ax plus by, this is a linear equation, right? So if you apply expectation, a will be the constant, apply expectation of x, b is the constant, apply for expectation of y. Okay. Similarly, constant of expectation is, you'll get same. Constant of expectation of 1 is 1 only. Okay. Fine. Next. These are some of the formulas you can remember ma. Clear? What is time? Already done na? Okay ma.